Hello everyone. Today we are learning about motion in a straight line, which is the chapter 3 of your NCERT of class 11th. We are going to follow through your NCERT and cover the most important points, and I will be teaching in English as well as I will be using some words of Hindi. So it will be a dual and a mixed language classroom. Firstly, the first point in the introduction of the chapter itself, it is given rectilinear motion. What exactly is rectilinear motion? Study of motions of object along a straight line is known as rectilinear motion. कि किसी भी ऑब्जेक्ट अगर स्ट्रेट लाइन में मूव कर रही है तो उसकी स्टडी करेंगे, तो दैट इज रेक्टिलिनियर मोशन. अब रेक्टिलिनियर मोशन इज अ सब टॉपिक अंडर काइनेमैटिक्स. मतलब काइनेमैटिक्स के अंदर क्या आता है? रेक्टिलिनियर मोशन. What is kinematics? Kinematics is simply the study of motion. We are not going into details कि why, how, etc. in kinematics. हम लोग सिर्फ पढ़ते हैं कि मोशन हो रहा है, उसकी वजह से what are the mathematical expressions and consequences, not what and why. And then we are talking about, there is a discussion on the topic called point objects. What exactly are point objects? इस चैप्टर में वी विल ट्रीट एवरी ऑब्जेक्ट एज पॉइंट ऑब्जेक्ट. यहाँ पे जो अप्रॉक्सीमेशन ले रहे हैं, दिस अप्रॉक्सीमेशन इज वैलिड सो फार एज द साइज ऑफ ऑब्जेक्ट इज मच स्मॉलर देन द डिस्टेंस इट मूव्स इन अ रीजनेबल ड्यूरेशन ऑफ टाइम. ओके, लेट अस टॉक अबाउट कि सपोज वी हैव एन ant and ant needs to move a distance of 1 meter. We see the size of the ant and 1 meter length. We can say na कि ant is very little as compared to the size it has to travel within, let's say, 1 hour. But if the same thing applies for an elephant, we can't talk about an elephant moving 1 meter only, na. Its own length is longer, na. So it's not comparable. So we will not say that elephant is a point object, but in the case of ant, we can say that it is a point object. Then the third topic, it is the actually 3.2. When it starts, we talk about position. What exactly is position? We usually take a normal coordinate axis system. We study in 9th, 10th. There's the x-axis, y-axis and z-axis or z-axis, whatever you call it. This point is origin where 0, 0, 0. This is our reference point for anything. Let's say we have a point P. Its coordinates are A, B, C. A is x coordinate, B is y coordinate, and C is the z coordinate. Okay, this is simply how we define position using A, B, C and coordinate axes. And ज़रूरी नहीं है कि x, y, z ही हमारे coordinate axes लिए जाएं. R, theta, phi, simply so many different coordinate systems. This is the most usual one हम use करते हैं. आगे जाके और भी यूज़ करेंगे एंड वी विल लर्न अबाउट देम एज वी गो हेड. एंड ऑल्सो वन मोर थिंग, इफ वी एड द क्लॉक टू द सिस्टम ऑफ रेफरेंस or the coordinate system, so this system is now can be called as frame of reference. What is simply frame of reference? कि कोई भी frame मतलब coordinate axis या measurement का system position के लिए जिसके साथ आप clock add कर दें, जहाँ time नोट कर सकें, that is frame of reference. And then we go ahead and learn about what is path length and what is displacement. Okay, the path length मतलब example के through यहाँ simply I will be teaching you what is path length and what is displacement. Path length is nothing but distance firstly. Okay, suppose one person starts from P, then goes to Q, then R, then S and then back to P. What exactly are these things? कि PQ plus QI plus RS plus SP. This is 10 meter I have given, this is 8, this is 10, again 8. Then simply path length या distance क्या होगा? इन सब का sum. The sum total of all the distances traveled here. Distance means literally P to Q. That is comes out to be 36 meter. Then we go to describe displacement. What exactly is displacement? Mathematically we write it as delta x. Delta means change. Okay, and then xf, f means final, I means initial, ki x final minus x initial. These are just the position coordinates of final, and this is initial one. What exactly is this? We start from P to Q, then Q to R, again all these things. But the thing here is, in displacement, we see that P and PQ versus SR are parallel. What happens is, P to Q, if we suppose it's positive, then R to S, it is moving opposite to this. This is minus. Okay, and similarly for 8, and this is minus 8. So the overall net displacement comes out to be 0. That is, if we are moving from one point and come back again at that point, then the displacement is 0, but the distance or path length exists. कुछ वैल्यू होता है डिस्टेंस का. अगर हम P से वापस भी आए घूम के, चाहे सर्कल हो, रेक्टेंगल हो, या आर्बिट्री कोई भी पाथ हो सकता है, वही डिस्प्लेसमेंट है. अगर उसी जगह वापस आ रहे हैं तो इट कम्स आउट टू बी 0. इसलिए हम लोग बोल देते हैं कि पाथ लेंथ या डिस्टेंस क्या है? स्केलर क्वांटिटी. मतलब वो क्वांटिटी जिसमें सिर्फ मैग्नीट्यूड है, डायरेक्शन नहीं है. मैग्नीट्यूड क्या होता है? सिर्फ वैल्यू. और डिस्प्लेसमेंट की बात करें तो डिस्प्लेसमेंट क्या है? वेक्टर क्वांटिटी. उसमें मतलब मैग्नीट्यूड भी है, डायरेक्शन भी है. Both magnitude as well as direction. It can be both positive and negative. क्योंकि क्या है, अगर हम एग्जाम्पल सोचें कि P से Q जा रहा है, फिर R, फिर S, फिर P पे पहुंच गया, तो वो क्या करता है? फिर वापस आ गया. इफ वी गो दिस पाथ, तो क्या अब PS क्या हमारे लिए? नेगेटिव है ना, तो हमारा डिस्प्लेसमेंट क्या आएगा? -8 मीटर. इट कैन बी सेड, कोई प्रॉब्लम तो नहीं है इसमें. नेक्स्ट वी लर्न अबाउट एवरेज स्पीड्स एंड वेलोसिटी. बेसिकली स्पीड, वेलोसिटी, डिस्टेंस, डिस्प्लेसमेंट हम लोगों ने पहले ही पढ़ रखा है 9th 10th में, एंड वी आर रिवाइजिंग इट. बेसिक्स वापस से कर रहे हैं 11th में. ओके, अब सबसे पहले जिसे हम स्पीड या वेलोसिटी 9th 10th में डिस्क्राइब करते हैं, वो क्या होता है? हमारा एवरेज स्पीड एंड वेलोसिटी. एवरेज स्पीड, एवरेज वेलोसिटी. एवरेज स्पीड, हाउ NCERT डिफाइंस इट. मैंने ये NCERT से ही कॉपी करके पेस्ट किया है. व्हाट वी आर टॉकिंग अबाउट हियर इज कि एवरेज स्पीड इज डिफाइंड एज द टोटल पाथ लेंथ ट्रेवल्ड डिवाइडेड बाय द टोटल टाइम. ओके, द टोटल, emphasis on total, during which motion has taken place. So average speed is total path length upon total time interval. Similarly, when you go to average velocity, a velocity is defined as the change in position or displacement. We have learned that displacement is delta x, right? Change in position, and then upon change in time, how much time we have taken to cover that distance. That is simply average velocity. And define and notation is simply v with the bar. This is standard notation, and it gives x2 minus x1 gives the change in position of x, or the thing, basically the change in distance या displacement, not distance, displacement, upon t2 minus t1, that is delta t, delta x upon delta t. And the SI unit we know is meter per second. Now here we're talking about these. This is showing that average velocity can be positive, negative, and 0. How we talk about this? This graph shows how x varies with t. Position time graph. कि time क्या था, किस time पे particle कौन सी position पे था. We can see that where the particle was at a given time, and we plot it. When we plot it, we see that delta x, like x is, t is also positive, x is also positive, so the value comes out to delta x by delta t is positive. Why? Otherwise similarly here the delta x is negative but the t is positive. Delta t is positive, delta x negative, so this comes out to be negative. Similarly we are talking about कि पोजीशन बदल ही नहीं रही टाइम के साथ, द पोजीशन इज नॉट वेरिंग विद टाइम, तो अपने आप वी कैन अंडरस्टैंड दिस बिकम्स 0. ओके, सो दिस इज पॉजिटिव, नेगेटिव एंड 0. Here delta x was also positive, delta x negative, delta x 0. Now we come out to learn about instantaneous speed and velocity. What is instantaneous speed and what is instantaneous velocity? यहाँ हमने बात किया average का. Then we are talking about the term instantaneous. What exactly is instantaneous? Instant in English means at the given moment. उसी टाइम पे. तो उस टाइम पे या एक स्पेसिफिक टाइम पे क्या स्पीड है एंड व्हाट इज द उस टाइम पे क्या वेलोसिटी है, उसे हम बोल देंगे इंस्टेंटेनियस वेलोसिटी. दैट इज एवरेज वेलोसिटी टेल्स अबाउट हाउ फास्ट एन ऑब्जेक्ट हैज बीन मूविंग ओवर अ गिवन टाइम इंटरवल, but does not tell us how fast it moves at different instant of time at during given interval. We define instantaneous velocity of simple speed simply velocity v at instant t. Okay, let us just see from this example I have written here. What I am doing is simply, okay, a person goes from point A to B, then B to C, then C to A. ओके अभी हमने बात किया था हाउ वी कम एट द सेम प्लेस आफ्टर रोमिंग अराउंड फॉर सम टाइम, देन द डिस्प्लेसमेंट कम्स आउट टू बी 0. We just learned na that from A to B then back to B to A. That means we have completed our circle again. So the displacement is 0. If the displacement is 0, that means velocity, average velocity is what? Displacement upon time. Whatever the time is, but the delta x is 0. So average velocity is 0. We can say that. There's no issue. But at a given time, if we're talking about this interval, when we travel from A to B, we're not considering B to C or C to A, we can see that the average velocity or the velocity at any given point is 10 km per hour. Then after some, then for B to C it's 20 km per hour. Then C to A is 5 km per hour. So whenever we measure the at an instant here, suppose, so the velocity comes out to be 10 km per hour. In which direction you have to mention the direction A to B. Similarly, whenever we mention like some point here from B to C, the instantaneous velocity comes out to be 20 km per hour. But the direction is B to C. This is simply what we are talking about, that the instantaneous velocity and the average velocity are not same. They're two different things. Whenever we talk about a sample point of time, like I say, at a point C, what is the velocity? Then we can take the average of these two, na? That's not a big deal. But remember, for uniform motion, that is, our person is moving with the constant speed at all times, at constant velocity at all times, then the average velocity and the constant velocity are the same. Instantaneous velocity and the constant velocity or the average velocity is same. Then if we define instantaneous speed, what is instantaneous speed? It is simply the magnitude of velocity at a given point. We talk about A to B, the instantaneous speed is simply 10 km per hour, but we don't talk about the direction there. Here in velocity we talk about direction. In speed we don't talk about the direction. Simply that is the difference between both of them. And also we have written here a thing, the definition, like V, which is the instantaneous velocity, is simply limit of delta x by delta t, where t approaches 0. This is a screenshot from Ncert itself. What we are talking about, LIM, is nothing but limit. Limit of something. You put limits like दायरा. हिंदी में वो बोलते हैं ना, दायरा लगा दिया, किसी पे बोल दिया कि ओके just don't cross this, कि you can't go over this or go less than this. तो that is limit. लिमिट क्या है यहाँ पे? डेल्टा टी अप्रोचिंग ज़ीरो. डेल्टा टी अप्रोचिंग ज़ीरो मतलब कि टाइम बहुत छोटा है, कि एकदम बोला हमने कि ओके एट टी इज इक्वल टू 15 सेकेंड्स व्हाट इज़ द इंस्टेंटेनियस वेलोसिटी. तो 15 सेकेंड का मतलब ये नहीं है कि 14 सेकेंड में बात कर दिया या तुमने बोल दिया 16 सेकेंड पे था वेलोसिटी. वी आर टॉकिंग अबाउट 15 सेकेंड्स ओनली. सो द टाइम शुड बी वेरी एग्जैक्ट. चेंज इन टाइम इज वेरी लेस. That is delta t approaches zero. कि delta t change in t is very less, so less that it approaches zero, कि वो लगभग zero के बराबर है. तो we have delta x at that time and delta t at that time. And we have learned calculus and therefore we can write this as dx by dt. Again the standard notations. You have to learn them. इसका कोई शॉर्टकट नहीं है, ये आपको समझ आना चाहिए और याद करना पड़ेगा. नॉर्मली हम लोग कैसे डिफाइन करते हैं? v इज इक्वल टू डी एक्स बाय डी टी. नॉर्मली वी टॉक्स अबाउट इन द टर्म्स ऑफ इंस्टेंटेनियस स्पीड एंड वेलोसिटी ओनली. नेक्स्ट वी शुड टॉक अबाउट एक्सेलरेशन. व्हाट एग्जैक्टली इज एक्सेलरेशन? एक्सेलरेशन इज द रेट ऑफ चेंज ऑफ वेलोसिटी विद टाइम. वी हैव लर्नड दैट v इज चेंज ऑफ डिस्प्लेसमेंट विद टाइम, पोजिशन basically. Change in position of object with time. Then acceleration is rate of change of velocity, that is change in velocity over time. So simply average acceleration in parallel to, जैसे वहाँ पे v बार लिखा था यहाँ पे a बार लिख सकते हैं. There's no issue. v बार parallel a बार simply. So this is v2 minus v1 upon t2 minus t1. v2 is what? Velocity at time t2. v1 is velocity at time t1. And overall this is v2 minus v1 is change in delta v, and t2 minus t1 is change in t. That is velocity upon time. Change in velocity upon change in time is average acceleration. Then we talk about instantaneous acceleration. वहाँ पे हमने बात किया था एवरेज वेलोसिटी का, यहाँ एवरेज एक्सेलरेशन का बात किया. सिमिलरली वहाँ इंस्टेंटेनियस वेलोसिटी था, यहाँ पे इंस्टेंटेनियस एक्सेलरेशन है. सेम कंसेप्ट. वी आर टॉकिंग अबाउट अ सिंगल पॉइंट एट अ टाइम t. व्हाट इज द एक्सेलरेशन देन? व्हाट इज द एक्सेलरेशन डिफाइंड एज? वहाँ पे लिमिट दिया था t, डेल्टा t इज ज़ीरो सिमिलर, लेकिन वहाँ ऊपर क्या था? डेल्टा x. यहाँ क्या है? डेल्टा v. व्हाट इज है? लिमिट t टेंड्स टू ज़ीरो, डेल्टा v अपॉन डेल्टा t. That is, we can write it in calculus form, dv by dt. That is, instantaneous acceleration is dv by dt. See, average is a bar. Normal acceleration, what we talk about is a. This is the one we use in everyday life and furthermore in the chapter. Whenever we are going to do numericals, this is what we are talking about. A is dv by dt. सिमिलरली यहाँ पे हमने v जो पढ़ा था इंस्टेंटेनियस, v इज इक्वल टू डी एक्स बाई डी टी. दिस इज गोइंग टू बी यूज बाई यू इन न्यूमेरिकल्स. नाउ वी आर टॉकिंग अबाउट, अच्छा कि सिमिलरली वी आर अगेन ड्रॉइंग पोजीशन टाइम ग्राफ. पहले क्या था? वी सी दैट इट इज कांस्टेंट, दैट इज इट इज अ यूनिफॉर्म मोशन. यूनिफॉर्म मोशन मीन्स देयर इज नो एक्सेलरेशन, वेलोसिटी रिमेन्स सेम. वेलोसिटी में कोई चेंज नहीं, तो मतलब एक्सेलरेशन इज, दिस टर्म इज अबव इज ज़ीरो, सो एक्सेलरेशन बिकम्स ज़ीरो. बट व्हेन वी आर टॉकिंग अबाउट एक्सेलरेशन, वी आर टॉकिंग अबाउट चेंज इन स्पीड. सो वी कैन सी दैट एक्स चेंजेस विद टाइम इन पैराबोलिक फॉर्म. पैराबोला बनता है एंड वी हैव पॉजिटिव ए, नेगेटिव ए एज वेल. ए इज इक्वल टू ज़ीरो. That is, there is no acceleration, uniform motions. And next topic is velocity time graph. You should learn the basic thing ki velocity time graph. What is velocity time graph? Similar to position time graph, where x or position, basically what we are talking about is that at your y-axis and x-axis is your time taken. Similarly, at velocity time graph, what we are talking about is simply velocity versus time. We plot velocity on y-axis and time at x-axis. The first one is motion is in positive direction with positive acceleration. दूसरे में what we are talking about is motion is in positive direction with negative acceleration. That is, यहाँ पे we are racing the car. This is where what we are doing, brake लगा रहे हैं. We are putting the brakes on the car. And then the C option is motion in negative acceleration changes direction at time t1. Okay, that one is last one. Talking about negative speed and negative acceleration. Okay, let us assume कि हम लोग देख रहे हैं तो हमारी तरफ से गाड़ी दूर जा रही है. So that is this one. When we are talking about कि okay, the last one is नेगेटिव एक्सेलरेशन है गाड़ी का. यहाँ पे आके ब्रेक लग रही थी गाड़ी को, बट व्हाट हैपेंस इज इट्स डायरेक्शन चेंजेस एट टाइम t1. की पहले हमारी तरफ आ रही थी गाड़ी, ब्रेक लग रही थी, फिर गाड़ी आके एक पॉइंट ऐसा आया कि उसका वेलोसिटी 0 हो गया एंड इट टर्न्ड अराउंड. ओके, नाउ द कार इज मूविंग इन ऑपोजिट डायरेक्शन. And the thing we have to learn this under this is velocity time graph for any moving object. What happens here is area under the graph. मतलब जो V वाली लाइन बनाई हमने, V मूव कर रहा है along with T, उसके नीचे जो भी एरिया आया ये वाला, this area represents the displacement over a given in time interval. What is this area? Displacement. This area, complete one. You have to complete it like whole. This is again displacement. Here, this is displacement. Here, this and this is in last graph, this and this is displacement. This one becomes a positive, this one becomes negative. So overall their sum comes out to be the net total displacement. And then the last but not the least but the most important topic of today's class is the kinematic equations for uniformly accelerated motion. What I am going to use is simply I will do it by the calculus method. Okay. What I am using is calculus method. NCERT uses a graph, but I would prefer everyone learns it through calculus method. It's not hard to learn nor it is easy to learn. You don't have to learn it. In fact, sometimes you have to do the numericals, but you should understand how we derive these three equations which are very important to us. Okay, firstly, what we have learned, we are using only those things we have learned today in this lecture only. The first thing we are going to use is the formula A is equal to dv by dt. Second, we are going to use velocity is equal to dx by dt. Then rest we already know. Firstly, we write acceleration. I told you we will use this. Acceleration is equal to dv by dt. What acceleration is this? Instantaneous one. I just not writing the full form, but A is equal to dv by dt. अब कुछ नहीं करना, dv is equal to multiply हो सकता है ना, dt उधर चला गया, A dt. Not a big deal. What we do, because this is derivative, this is also derivative, what we do? Integrating both sides. Integrate किया both sides को, ये dv बन गया. This is A dt. What is this? हम लोग बात करते हैं हर बार dv. dv को क्या लिखेंगे? Velocity of final minus velocity of initial is equal to acceleration को क्या रखो? Acceleration is acceleration. It is independent of time. और dt का क्या होगा, t, है ना. वी कैन डू दिस. लेकिन t की लिमिट्स क्या है, हमने मान लिया, चलो जब हमने शुरू किया था तो t इनिशियल क्या है 0, t फाइनल क्या है t. प्रॉब्लम वाली बात तो नहीं है कि हमने जब whenever we started making readings or taking readings, the time is assumed to be 0, and when we stop the stopwatch the time is t. We usually write vf or the v final velocity. This is simply written as v most of the cases, and v initial is equal to initial velocity is written as u. Okay, then we write it as v minus u is equal to a t minus 0. This is v minus u is equal to a t minus 0. Simply we can say that v is equal to u उधर जाके प्लस हो गया, this is a t. v is equal to u plus a t. The first equation is v is equal to u plus a t. We can see simply again, a is equal to dv by dt है, then dt को a से multiply कर दिया, that side dt went here, dv is equal to a dt. Since they are both derivatives, we learned that in previous appendix. Whenever we start physics, we learn about this, na? So dv is equal to a dt. Then we started integrating both sides. It comes out to be dv is equal to a dt, and we integrate this. So dv is simply vf minus vi, a t, initial time 0, final time t, and v is final velocity, u is initial velocity. Then we have to do the second part of for the second equation. Now you write this as 1, mark this as 1. Now what we are going to use is v is equal to dx by dt. Again this is instantaneous. Velocity. Otherwise it would be v bar. If we are taking average, it is v bar. But we are using instantaneous. V is equal to dx by dt. Again multiply. Dx is equal to v dt. Simply integrate. Dx is equal to v dt. X है, xf and xi. This is the initial one, this is the final value of f. X. V is constant as compared to t, is it? Can we write v constant? No, here we had a is constant, but v is not constant. V is what? We wrote at, use equation 1. Okay, हो गया u plus at dt. Okay, now what we have is xf minus xi is equal to u dt plus a t dt. U is constant, velocity is constant, initial velocity है ना. We're not talking about velocity as whole, that is this velocity. We're talking about initial velocity. Okay, what is initial velocity? Let us just define this as vf only, okay, because this will create confusion otherwise in the end. This is u dt. T is what? Dt is t, 0 and t. A is constant, t dt. U t, because other terms become 0, minus term is 0, plus a. T dt is t square by 2, and limit again is 0 to t. Whenever we put this, it becomes half a t square. The other term again comes out to be 0. The next page we can write xf minus xi is equal to ut plus half at square. Now this is delta x displacement, right, is equal to ut plus half at square. डेल्टा एक्स को और क्या लिख सकते हैं हम लोग, एस, वी डिनोट एस डिस्प्लेसमेंट. इज इक्वल टू यू टी प्लस हाफ ए टी स्क्वायर. दिस इज आवर इक्वेशन नंबर 2. Then we go for the third equation, which comes out as simply what we have here is a क्या होता है, dv by dt. What I do is simply I divide it by x and multiply it by x. Sorry, dv by dt. No, this is how we do it. What is dv by dx by dt? V. This is dv by dx. This term is v. The other terms carries out same. Now what we do is simply a is equal to v dv by dx. What happens here is we cross multiply. A dx is equal to v dv. No issues. Again integrate. A dx is equal to v dv. Okay, a is constant, so a comes out of integration. What is left is dx. V dv is v square by 2. What is the final velocity? Vf, initial u, and a dx is x, x final, x initial, and here vf square minus by 2 minus u square by 2. What we do here is we had a with xf minus xi. Here we have vf square minus u square by 2. What we do is xi minus xf minus xi was what? Delta x, which can also be written as s. So this is a s, and we multiply the 2 this side, is equal to vf square minus u square. That is vf square minus u square is equal to 2as. This is our third equation, equation 3. Write the 1, 2, 3 again. The first equation was v is equal to, that is vf is equal to u plus at. Second equation comes out to be v is equal, s is equal to ut plus half a t square. Third one is v square minus u square is equal to 2as. You have to learn these equations. These are the 3 backbones of our kinematics, uniform motion basically. We will use this in the following numericals. We will carry forward this classroom tomorrow, and I will be teaching you some numericals from NCERT, some carry forward numericals from examples itself from the NCERT again, and then I will give you some numericals from NEET paper or the JEE mains level. I hope it was a good session. You guys can give me some advices and suggestions in comments. I will try to follow them. Thank you everyone.